Okay, welcome back. So in this problem, again, your team A already went through it. They underlined, they created their constraints, they identified their unknowns. So you can go ahead and pause it, underline, write down your constraints. Your partners will go through it with you. I'm just going to speed through what we did and how we developed our feasible region. So we have a problem about an area in a parking lot that fits 600 square meters. We have cars and buses that are going into the parking lot. Any car that goes in requires 6 square meters, and a bus that goes in requires 30 square meters. There's an attendant that works that can only handle 60 vehicles. And we're going to be looking at what are we charging the cars and buses, because in this case, we want to try to maximize our income. So what Team A did was they developed that our unknowns were how many cars and how many buses were going in. So those were our X and Y's. We developed our first constraint based on our area, because our cars take 6 square meters, our buses take 30 square meters, but in total, I can only fit 600 square meters in the parking lot. So I can fit less than that, or I can fit equal to 600. My second one was, what is my attendant able to handle? That's another constraint, right? Because he can only handle 60 vehicles. So how many cars are going to go in, plus how many buses, need to be less than or equal to 60. Okay? Now if you notice here, you have X is greater than or equal to 0, Y is greater than or equal to 0. What that does is it puts me in the first quadrant. The reason why we want to work in the first quadrant here is because we can't have negative cars, we can't have negative buses, right? So it's going to be X is greater than or equal to 0. I could have 0 cars, I could have 0 buses, but I want to be in the first quadrant here. That's why I have this already highlighted, because my X is greater than 0, my Y is greater than 0, so all of this is already highlighted. It's going to depend on those two constraints to figure out where am I exactly going to be in my feasible region. So now we graphed it. You can go ahead and take a second to pause, get your graphs. We went up by 5s, went all the way up to 100, went up to 60. We connected 60 and 60. That's for this constraint. We connected 20 and 100. That's for that constraint. Okay, and then we developed our feasible region because they were less than or equal to. We erased everything that does not fit within our feasible region, and we developed this nice 4-shaped figure, I guess. Now, if you remember from the first part of the video, we looked at our vertices, and those are going to be our best methods to be able to maximize this income, because if you see, there are unlimited amount of points and solutions in this feasible region. That's going to take me forever to figure out which point is going to get plugged into my income function. So what's going to be the best thing for me to do is grab those vertices, those corners, and plug those in to my income function. Now, what is my income function? What is my objective function? What am I trying to maximize? Well, if you take a look at here, my income is telling me every car is charged $250 and every bus is charged $750. That's what I'm making money off, folks. That's how I'm going to make my money. So X is representing cars, Y is representing buses. I charge $250 for the cars. So my income is going to come from me charging $250 for each car coming in. That's my income. Plus, it's also going to come from my buses. What am I charging the buses? $5 more. $750 for those buses. And this is going to be my income function. That's my objective function. That's what I'm going to try to maximize here to find out what's the maximum income. So let's go ahead and grab those vertices. Now, 0, 0 is really not going to count. So if I plug in 0, 0, what's my income? 0. No one